Okay, so again, take problem number 7 from this handout we did. And like I said, I didn't write it, so it's not really my problems, but we can use these problems to, to review. Those are good. And just rewrite the one that goes across, rewrite it up and down. So there it is there, rewritten. All I've done is rewritten that one. And now I want you to take that and translate these points, write 3, and then take the original points and find the inverse. All right, so let's see. So I'll give you, let's start with the right 3. So the right 3, if I have a point, and maybe even on the exam, feel free to make yourself a little tiny grid here and find the points if you need to. -2 means back to, first you go to, you walk to the elevator, then you go up or down, and then you go up to the 3rd floor. So back this way and then up to the 3rd floor. And if I'm gonna translate this right 3, it's gonna go 1. It's gonna have 1, 2, 3. It's gonna end up right here. So that's at, where is that? That's at 1, comma 3. And it was at -2, comma 3. So do that if you need to, right? And you can see, oh, what changed? The y didn't change. The x changed. It became 3 bigger. So all these, the points are straight up. They don't change. It's not left as, it's just regular. It's just what they are. So right 3, this one becomes 3 bigger. This one becomes 3 bigger. 3 bigger. This one becomes 3 bigger. And the y stays the same. Right? You can see from that how that happens. Now the inverse, does anyone know what's up with the inverse? Someone done the inverse one already?
X's and Y's swap.
The x's and y's swap. Exactly. So go back to the original, and the x's and y's swap. -2, 3 becomes 3, -2. All right, so what else should we look at? This one might be a tricky one. Okay, so let's look at at 8, 9, 10, 11. Looking at their I guess for all of these.
Can I ask a question about the last one?
Sure.
How do you determine the domain and range from that information?
Okay, so this one should look, 11 should look somewhat familiar. Let me see if I can pull it up.
For 7, yeah. They were asking, unless you're not going to ask that on the test.
I won't actually ask one just like that. I'll probably stick with more the ones like, I probably won't ask 11, honestly. I think I will ask other pictures.
Oh, no, I'm talking about 7.
Oh, 7?
Yeah.
7?
7, yeah.
How do you tell if it's
Determine the domain and range.
Oh, okay. So if they're points, then their domain and range are just some points. If they're curves, then the domain and range is the whole piece. So that's a good thing to note. So above the domain and range, so first of all, is 6 a function or not? So that's a question. Is it a function or is it not a function? Let's start with 7 since we already have 7 kind of up. So I guess the question is this a function or relation? And why? All right, so I want to take a look at just this first one here. Is that a function or relation? Y. Somebody needs scratch paper. I'll hang out with those scratch paper. People have some scratch paper. So is that a function or a relation? What's up with functions or relations?
Functions, if all x's have, there's like
Yep.
only one,
Only one answer, only one Y.
only
Yeah.
one y, and then
Right.
relation between multiple y's.
Right. So for a function, every x can have only one Y. In other words, it can have, I got it. In other words, every input can only have one answer, one output. So are there any inputs here that have more than one output?
No.
No. If I put in -2, I know what I'm going to get. If I put in 0, I know what I'm going to get. If I put in 2, I know what I'm going to get. If I put in 4, I know what I'm going to get. If I had this, for example, 0,6 or 5, then it'd be trouble, because if I put in 0, I don't know what I'm going to get. I could get 2 or I could get 5. Does that make sense? But here, since every x has only one answer, then we're good. So it is a function because every input, which is x, has only one output, y, or answer. Okay, good. Now, everybody take a look at the next one, at number 6. Is it a function or relation?
Yeah.
So I had a couple people say relation. What does everyone else think?
Relation.
Why is it a relation? Because what?
One.
Yep.
Has more than one output.
Yep. Has more than one output. Right, if I input 1, I could get 3 or I could get 5. Okay? Now everybody use set notation and give me the domain. Ooh, the last one. I didn't have you give me the domain and range. So back to this one here. What's the domain and what's the range for number 7? For this one. So we have domain. We have range. Domain, remember, domain is what you start with, what all your x's are. The range is what you can go to, right? How far can you range? What your outputs can be. All right, so my domain, what can x be? X can be what? Yep, it can be -2. X can also be 0. It can be 2. It can be 4. So we put those inside the squiggly lines. So set notation means you put it inside, just write it as a set, actually, it's fine. Just put it inside squiggly lines. I'm not going to ask for you set notation. That's just kind of X's, given. I'm not going to do that. We'll just have it be, write it as a set. It's fine. Why can't I not put why can't I put from -2, why can't I do this? Like I did for other ones. Why can't I do that? Because it's just points. Right, what happens when x is -1.463? I don't know when x is -1.463, I don't know what to do. There's nothing tells me where it goes. Does that make sense?
Yeah.
So that's the difference between, okay, so I'm gonna find the range. What's the range? Work on the range. I'm gonna find the range. Write it down. Okay, so the range is 3, 2, and 6. Do not write 3 twice. If you write 3 twice, you're not going to get points on this. Right? Remember, the range is the list of all possible outputs. So 3, 2, and 6 are the possible outputs. You can put them in order or not in order, doesn't matter. But you know, you should have them all listed, and you should not list 3 twice. Everybody on board? Okay. Now, how does that differ from here? Here, it's not just that x isn't just, this point is 2, 2, but then this point is 1, -2. However, can I find when x is 1.143? Eric, can I find when x is 1.143?
No?
Yeah, does it exist? Would I be able to sort of approximate it when x is 1.413?
Yes.
Yeah, I mean, it's probably like right around here somewhere, right?
Oh, yeah.
Do you see what I'm saying?
Uh-huh.
I could find it. Whereas with the numbers, when x is 1.413, I can't find that at all.
Okay.
Does that make sense?
Yeah.
So that's why that range is just those points. And that domain is just those points. Here, my domain and range, my domain is going to be everything from -4 all the way to 2. Does that make sense? And everything in between. So that's the difference between those two spots, is that this one is just my domain is from -4 to 2. It's what my x's are allowed to be. So you can sort of think of it like, you know, what are my x's allowed to be in terms of my width, just from there to there. So that's from, what am I, -4 to 2.
Oh, you just read it like that?
Right. So everyone found the range for number 9. What's my range? In other words, what's the lowest it goes, what's the highest it goes? So right here, find the domain and the range. Remember, domain is all about my left-right. The left, furthest left it goes, the furthest right it goes. Range is the lowest it goes, the highest it goes, my y's. Got it? Are you down yet?
I just forgot about those points, it's been so long.
Yeah, exactly. It's been so long. That's why we need to review. So let's be a little Christmassy about this, I guess. Red. So the highest it goes is there. The lowest it goes is there. So my range is going to be from, what's the lowest it goes?
-2.
-2. What's the highest it goes? 3. Good. All right, so then now let's jump back and look at number 6. Oh, wait. First of all, we're on number 9. Is this a function or a relation? What are you focusing? Function or relation? How do you figure out from a graph if it's a function or relation?
The bars.
The vertical line test? Draw that vertical line, and you move it along there and see if it hits any spot more than once. Like moves away from it and it comes back to it, not right next to it. That doesn't count.
So it's function.
Yeah, this is a function. Okay? Why it passes the VLT, vertical line test. Okay, so now, let's pop up to number 6. We recognize it's a relation, but I want you to find the domain and the range. So find the domain. And find the range. Put it in his sets. And then when you're done with that one, go ahead and go on to 8. Again, is it a function? Find the domain, find the range. Look. So the top one, domain, what can x be? Well, let's see. X can be 1, 2, and -2. Don't write 1 again, because this is just a list of all things it can be. Right? Wouldn't say, yeah. So, and the range, what can the y's be? 3, 4, and 5. Squiggly lines. Okay, good. Now number 8, is this a function or a relation? What do you folks think? It's a relation. See how it hits here twice? It comes away, not right next to each other, but like it hits it and then it goes away from it and then it comes back and hits it again. So that is a relation. It fails the VLT. Okay, so now we need to find its domain and its range. So let's see, the domain. And folks come up with for the domain.
Negative infinity, comma 2.
Yeah, it starts off way, way, way off to the left. Way over here. And then that's how far this left it goes, and then the right, it stops here at 2. It can't go any further right than that, and then it comes back out to negative infinity. So negative infinity to 2. Negative infinity to 2. Can you ever touch negative infinity?
No.
Nope. So it's a rounded bracket. Can you touch 2?
Yes.
Yes. So that's a square bracket. Okay, how about my range? What's the lowest it goes? Al?
The lowest it goes is negative infinity to positive infinity.
The highest it goes is positive infinity, so that's its range. Good. All right. All right, this one might be worthwhile. Let's look at 10. I'm not as worried about 11, but let's stick with the 10. So 10, is this a function or relation?
Function.
What does everyone think? Function? Right, it passes the VLT. If I draw a line straight down, I only ever hit once. Passes the VLT. What's my domain? I'm gonna write down, I want to find the domain. Is it going to be a set of points or is it going to be a range?
Range.
Range, yep, because it's a line, right? It's everything along this curve. And then find the range. What did folks come up with for the domain? Furthest left it goes?
1.
1. It looks like it can touch 1. What's the furthest right it goes? That's infinity. Yeah. If you weren't sure and you put curved thing here at 1, I think I'd be okay with that, because you can't really tell. What's the range, Natalia?
-3.
-3. And we'll say it touches. You can't really be sure. If you put a curved one there, it's fine too. What's the highest it goes, David? Callie? Infinity, yep. It goes up and to the right forever. Okay, good. So let's take a look at, what if, say, I had something like, say, this. Is that a function or relation? Relation. Right, it fails the VLT. And then, say this is at 3, no, this is at, say, -4. This is at, I made it too symmetrical, 2 and 2. Think everyone would be able to give me the domain and range on that one? When we do it, okay, domain. What's the domain? -4 to 3. Ryan, what's the range?
-2 to 2.
Yeah, so I meant to write this in as, this is -2, sorry. -2 to 2. Good. And then last question I might ask you would be something like, here's a good one. F of x is equal to 2x plus 1 over 3x minus 4. Is this a function or relation? Oh, actually, I know, that's ridiculous because it is a function already. So what's my domain? This one. Well, maybe I'll ask if this is a function, sure. Is this a function?
Well, you said it was, but how do you tell?
Because it's got this here, right?
Yeah.
So it's a function, yes.
What do you mean, if it has a y, then it's a function?
Yeah, y equals something with x in it, it's a function.
No.
Yeah. And then what is my domain? I won't ask you for the range. I will ask you for the domain for this. So we should sort out that one. So as a reminder, whenever we're talking about functions, there are 3 things you can never ever do. What's the first thing you can never do?
Divide by 0.
Divide by 0. What's the second thing you can never ever do?
Square root of a negative number.
Square root of a negative number. And the third thing you can never do is you can never take a log where the answer part is negative, 0 or negative. So I'm not going to ask you that one, but that is something you should, it would be good if you knew. Like, so you can't have log 3 of -2. You can't do that.
It's DNA.
Yeah, does not exist. Yeah. So I'm not going to ask you those ones. However, I will expect you to know that you cannot take the square root of a negative number, and you cannot divide by 0. So here, do we have x in a square root? No?
No?
Are we dividing by x in some way?
Yes.
Okay. So make sure that you don't divide by 0. Everyone find that.
So this is 3x minus 4 is not equal to
Mm-hmm.